Most tongs are designed for one or two specific sections of material, though there is usually a bit of leeway in this. There are some meant for multiple sizes and shapes, so generally a jack of all trades is a master of none. It is important to have the right tongs for the right material, otherwise bad things happen, such as dropping hot metal or hitting yourself in the face with it. So today we're going to make some hollow bit tongs designed to be used with 12mm square section. We'll be using 12mm round bar for the rein, scarf welded onto some 12x30 flat bar. Start with the 12x30. Get a long heat on it so that it cools at a slower rate. To do this, put it in the fire to heat one end and then turn it around to heat the other. You need to put a set down about an inch from the end. The piece of 12x30 is about 8 inches long. I don't need this whole length, but it's better to have too much stock than not enough. Having 3 inches of metal still on the main bar rather than on the bit you're trying to work with is about as useful as a third armpit. Leave the set down fatter than the main material, about 16mm, as this will become the scarf. At this stage I swap the heavy hammer for a more accurate hammer. Quench off the material behind the set down as you're going to be upsetting the hot end. See, told you so. You want to upset it at an angle to form the toe of the scarf. You could equally do this straight down on the anvil. Watch my scarf welding video for more information on scarves. Form the scarf on the underside of the material so that it can sit flat on your anvil. If you do it on the narrow side, it will make it tricky to weld the two bits together without knocking the flat bar over. With the material lying flat, you have a better chance of a good tack weld with your first welding heat. Next, create a scarf on the round bar. The round bar will form the reins. Take a short heat and quench it if necessary. 12mm round, I find it easiest to upset it straight down on the anvil and at an angle so as to form the toe of the scarf. When you have the thickness, square it off a little and form the scarf itself. Build up your fire in preparation for welding. If you rake fuel on mid-weld, you'll lower its temperature. I place the round bar on top to preheat it while the flat bar goes in backwards to heat up the rear end. Remember, you need the rest of the metal to be hot or it will suck the welding heat out of the scarf. When the end of the bar is hot, turn it round to heat the scarf itself. And at this stage the round bar goes in as well, and I'll take a welding heat on both. It will be necessary to quench the toe of the scarves once or twice along the way to prevent them from burning. With everything in place, go for the first weld. Just tack the two bits of metal together. Don't try and fully weld the parts at this stage and you'll just make an ugly mess and blame me for it. 3 or 4 hammer blows and back in the fire. The second heat is the welding heat. Remember to only hammer the scarf itself or you'll be thinning the metal around the scarf and not actually welding. When positioning the work in the fire, make sure that only the scarf is beneath the fuel. This means that the scarf reaches a welding heat before the rest of the work starts burning, thus minimising wastage. A third heat is taken and used to blend the join and ensure that it's fully welded. I use the rest of the heat to forge the scarf to section and dress the material around it. A good scrub with a wire brush at this stage means my work will be clean and have a smooth surface. Don't bother brushing before this as you're just wasting your welding heat. A good straightening is usually in order at this stage as your work will be more bent than a banker after a bonus. With the part assembled, address the set down to a taper. With hindsight, I could have done the set down over the pick of the anvil and saved time as well as having a neater finish. Oh well. With the two halves at the same stage, I cut them down to the same length. This is done with a disc cutter rather than a chisel, as I can't be bothered dressing a chisel cut edge. It's also quicker. and mark the two parts 1 inch from the end. That section will eventually become the nibs of the tongs. Having marked the metal, I use a fuller for the next step, though you could equally use the bick of your anvil. This step separates the nib from the hinge blade. Once you've fullered the piece, dress the edges over the bick. You can see that I'm moving the part up and down over the bick in order to get some roundness in there. The next stage is to use a narrow cross peen to create the hinge plate. I'm doing this over the edge of the bick by forming down and inwards with the cross peen. This dislocates the material, creating the hinge plate and a boss, which we'll chat about in a sec. Once you've created the hinge plate, make sure that you dress it. I do it to an oval shape as the punching and drifting process will round it off for us slightly. With the hinge plate sorted, I dress the part at a red heat. This allows me to planish the metal and make it smooth. I could use a flatter, but I work alone and I find it easier with my broad-faced hammer. I also finish dressing the transition from the reins to the boss at this stage, followed by a chamfering of the corners, which looks a lot neater. Repeat all of the above until you have 2 matching reins. I mark the centres of the hinge plate by eye. I could probably do it using clever techniques, but I find my Mark 1 eyeball accurate enough. I usually give a quick tap with a punch and then inspect the mark to make sure that it's going in the right place. I'll then punch one side of the hinge plate and turn over. You can see the dark circle on the other side which marks the location of the eye. This is caused by the thinner metal on the outside of the hole cooling on the anvil. Punch through that in order to shear a slug, and use a pritchel hole on the anvil to eject it from the eye. I drive a drift through the eye in order to increase its size to 12mm round. If I'd punched the eye at 12mm to start with, the material around the eye would have been too thin. By drifting it out, I spread the size of the hinge plate around the eye as well, leaving me with a comfortable amount of material around it. After drifting, I give it a quick straighten and dressing. You'll notice the swelling above the eye. That is the boss. The extra material is needed because I'm going to offset the reins from the draw. This will allow the reins to line up with each other once assembled, which in turn gives you a firmer grip. The offset is a weak point because the process causes the metal to thin. The boss is there to counteract the thinning by bringing extra material to the offset. You'll need to quench the nibs and the rein transition to stop them from distorting when you bend in the offset. Place the metal with the boss just on the edge of the anvil and dislocate the material with sharp blows from the crossbeam. You want to move it by about a quarter of its thickness and it will only take 3 or 4 blows. Dress and straighten as necessary. One of the final steps is to dress the nibs themselves. This is more of a matching exercise so that both halves of the tongs match each other. The nibs need to be higher than the eye so that they don't foul each other once assembled. It's easier to do this at this stage rather than when the tongs are assembled. I give both half the tongs a good filing in order to tidy up the forge work. I run some chalk on the file beforehand as this prevents the teeth from clogging up with metal dust as well as lubricating the tool. No innuendo intended. The filing removes any sharp edges and makes sure that the hinge plate is smooth. Any roughness on there will affect the working of the tongs. The last step before riveting is to run the drift again through the eye, just to make sure that any deformation which has occurred is taken out. And now it's riveting time. I'm using 12mm round, the same material as the reins. This will provide a good solid rivet. I measure the combined thickness of the hinge plate to determine the length of the rivet. You then have to add 1.5 times the diameter of the rivet to stick out on either side. Quick as that. I test fit the rivet in place to ensure that it's loose. I do this because metal expands when it's hot and I don't want it to not fit when heated. In order to heat the rivet, I pat down the fire so that it's firm and just lay the rivet on top. This is to ensure that I don't lose it in the fire. Using the Pritchell hole, I push the rivet in place. I'm not bothering with a header or anything to ensure millimetre precision. I just hover the tongs above the anvil so that both ends will upset and form heads. I get this nice and tight. I then reheat the whole lot and dress the rivet heads with a ball peen to remove any sharp edges and ensure a closer fit. This also drives the hinge plates together to remove any wobble which may occur due to them being ill-fitting. So now that we've put all that effort into making such a tight fit, we need to loosen them up. Tongs aren't much use so they don't open and close. Reheat the jaws and quench off the hinge plate to rein transition, because you don't want this part to bend at all. Really, you only want the hinge plate and rivet to be hot. When you're ready, start wobbling the tongs open and closed. Don't try and hold them open first go, you'll only break something. Wobble them little by little. This will make the two hinge plates and rivet learn to live together in harmony. When they're opening and closing properly, lower them into the water, but keep opening and closing them as the shrinkage from cooling may make them seize up again. If you're very good at shapes, you'll have realised by now that because of the location of the hinge plates, the nibs are going to bypass each other. We now need to offset them, which is easy enough. Get the nibs hot and gently bend them with your hammer. Remember to bend them only halfway each though, or they'll bypass each other onto the other side. If they don't quite sit in line with the reins, pop them in a vise and use another set of tongs placed on the hinge plate to twist them straight. If you don't do this, whatever work you're trying to hold with the finished tongs will sit at a funny angle. Ta-da! So now that everything is nice and assembled, we need to put the hollow in hollow bits. I mark the centre of the nibs with a chisel. Again, I do this by eye, but then I've been winging stuff like this for years so I can get away with it. If you aren't this confident, then mark the centre with calipers and chalk and do your chisel line along that instead. With my mark in place, I heat up the nib and carefully chisel down through it to a depth of about 1/4 inch. I take my time with this as I need to make sure that the cut stays central. I then use a 90-degree groover tool which I made from my power hammer. This has a perfect 90-degree angle in it which I use to spread the slot out. Once both nibs are done, I find a piece of scrapped 12mm square which I put in the jaws. This aligns the nibs and ensures correct spacing when the jaws are closed. A few taps and a bit of dressing ensure that these nibs will stay fitted to this material. I then mark up both nibs and cut the end square. This looks a lot neater and the effect is completed with a bit of filing to dress the cut. The inside of the nibs are then given a quick file to make sure that there are no asperities to mark hot metal these things will be holding. Finally, I give the tongs a brush in order to clean them up and make them look the part. As you can see, they work just great. Thanks for watching and please subscribe for a new video every week.